In this video, I plan to introduce the concept of the chi-squared test for independence. It looks like X, but it's not. That's the Greek letter chi. And it's not, we write, it's the chi-square. It looks like chi, it's not. It looks like chi, it's chi. Okay, so as we get started, what we're trying to do is we're trying to see if the data we have matches what would happen if events were independent. Okay, so if you remember, if A and B are independent, if A and B are independent events, then what that would tell us is that the probability of A times the probability of B would be equal to the probability of their intersection. Okay, so if you remember, we looked at this in our last unit. We looked at Venn diagrams, and so we had some scenarios where here's A, here's B, this right in here is the intersection of those. We found some scenarios where this was a true statement, and we had some scenarios where that was a false statement. So we remember on the tests and quizzes, you would do things where you would look to see, are they really independent? You'd multiply the probability of A times the probability of B, and if it matched the probability of landing in this shaded region, you knew that A and B were independent events. Okay, so this is what we're going to be working from. So we've got, they give us this data set, and they say that there's 100 males that exercise regularly, there's 106 that don't exercise regularly, for a total of 216 males. And then females, it's 98 and 86 for a total of 184. Okay, so then they give us these sums. So what we can do is to find any, say this right here, that value is the intersection. If we want to find this probability, so we could say the probability of male intersecting with regular exercise, there we go. Well, that would be equal to, well, this was 110 over the 400. So if you pick a random person out of these 400 people mentioned, the probability that it's a male who exercises regularly would be 110 out of the 400. There you go. So what we're going to do, though, is we're going to then say, well, what happens if our expected value would be, let's assume that they're independent, and then we're going to take the probability of male, multiply that times the probability of regularly exercising, and see if these two things match. Okay, if they match, then we can say that it's an independent event. Well, in the real world, things won't match perfectly, but we want to talk about, we're going to have a way to measure to see how closely do they match, roughly. Okay, so in this one, the probability of being male, there were 216 out of the 400. And the probability of regularly exercising is 208 out of the 400. Okay, so this would be the probability of being in that particular region. Now what we want for the expected values is, okay, how many people would we expect to find in this value? Well, we can take the probability of being male times the probability of regularly exercising and multiply that times the number of people that we were considering. So down here they give you a nice little, I think I printed this page for you. So to find this first box right here, we're taking the probability of being male, I'm going to write it again, times the probability of regularly exercising, times the total number of people, which in this case is 400. So we said it's 216 over 400 times 208 over 400 times 400. Well, notice that cancels, and so basically we're taking this total times this total, and we divide it by 400. Let's see, where am I in my calculator? I don't know what I've been doing. Okay, so we had 216 times 208, and we wanted to divide this by 400. Well, that's not very helpful, calculator. Okay, so then I have 112.32. So 112 and 32 hundredths. And that's the expected value, assuming that things are independent of men that exercise regularly. So the actual value that we found was 110. We're saying 112 was our expected value. The next one we can say, to find the female right here, we're going to say 100 and, can you see what I'm doing? 184 times 208 divided by 400. Okay, this becomes 95.68. We can do the next one. If I want this one, I'm looking at my sums are 216 times 192 divided by that 400. All right, calculator, maybe I should. Where was I? 216, 192. So that's this box, 103.68. Where am I? 184 times 192. I'm going to say 0.0, so it gives me a decimal divided by 400. It still didn't give me a decimal. Huh, that's funny. Okay. I'm easily amused. 88.32 is that expected value right there. So what we have is we see the expected values, we see the actual values from our data set, and now we're going to compare the two. So on the next page, we take our observed frequency and then our expected frequency. So the observed, I don't remember what order I did this in the past, but 110, another observed value was, well, we'll just go down, 98, 106, and 86. So I'm pulling these values here and putting them in this little table. And then I'm going to take these same values. So since I did 110 would correspond with 112, and then the next one I did was 98. Can you see that up there? 98 would correspond with this 95. Okay, so my values 112.32, 95.68, 103.68, 88.32. Okay, and now if you remember how we found the standard deviation, we took the difference, but then so we're taking the difference next, and then we square it, because if you look at this, maybe you can see my calculator. When I say 110 minus 112.32, I get a negative 2.32. When I have 98 minus 95.68, oh, I did it twice, I get, oh, that's this one. That's a 2.32 right here. Well, if I just combine these, we're at 0, so that's not very helpful. So what I'm going to do is I'm going to square these values, and I get, well, both of those end up being, that's not enough space for me. 5.3824, we're going to keep that exact value. We might need more decimal places at this point. Okay, so that's in both of those. The negative squared becomes a positive. The positive squared still is positive. Let's find the rest of these differences. 106 minus 103.68. That number looks familiar, so this is a positive 2.32. And then this one, 86 minus 88.32. Okay, that's another familiar number. So in this column, all of these, this entire column is this 53824. So I'm going to take that number, I'm going to square that. Okay, so there's that number. I'm going to store that in my calculator as A, so I don't have to type it in every time. Okay, because what I'm doing here is that on each of these next things, I'm going to take that value, this number squared, which the whole column is the same, and I'm going to divide it by the expected value. So in each one of these, what I'm looking at here is, I'm going to say, okay, well, A, that value, I'm too lazy to type the whole thing, divided by 112.32. Okay, so here is the first, this is not big enough. Let's do 0.04792. We'll hang on to that many decimal places. Then the next one is I have A is going to get divided by 95.68, 0.05625. I know that this is more decimals than IB normally likes, but let's hang on to them because then you can see, we'll round later. Then I have A over the next one is this expected value is 103.68. 0.0519. How many decimals? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1. Okay. And then I have, the last one is 88.32. Okay, I'm too lazy to type all these in, so you know what, I'm going to come back. I should have stored them as other things. So the first one here, I can store that one as B. Okay, hang on. I can store this one as C. And then my calculator is remembering more decimals than I care to write down. I'm going to store this one as D. I have one more. I'm going to store this one as E. Oh, well, no, I'm going to do E because I'll forget in a second. E. It doesn't really matter. So now what I need to do is I need to find the total of all those values. So that was B plus C plus D plus E. Oh, see, I keep hitting F. Oh, nope. Oh, I'm ready for summer. Okay, and I find this 0.21703. So this is our calculated chi-squared value, 0.217, which is, and they're going to tell us this is rather small. I don't know, maybe they just said, the book said small. And that will indicate to us, so the difference those values were from the expected values, it's not very different. So that tells us that they are independent events. Okay, and now at this point, you can practice some of these, working through the idea of expected values, working through the idea of doing chi-squared by hand. But luckily, so it's this page, and then there's a little bit more, I think, for you to practice. And then, oh, it looks like, okay, the next page deals with, luckily, though, we can use our calculator to help us do these in the future. Good luck.